Transformations, notes on reflections. So a reflection is a transformation that uses a line like a mirror to reflect an image. For example, if you see the smiley face up here in the first quadrant, if we're reflecting it across the x-axis, here's our x-axis, it reflects it to be this upside down smiley face down here. Okay. So how do we do this in a coordinate plane? Well, if a point is reflected in the x-axis, its image is x negative y. So it starts as xy, changes to x negative y. What this means is that the x value in that coordinate point stays the same, but the y value, you take the opposite sign. Alright, so let's look at our example here. We have triangle TRY. Point T is at negative 1, 2, our pre-image. And you guys can just fill it in your chart, but my little pen thing here is a little bit too big, so I'm going to fill it in down below. So point T is at negative 1, 2. Okay, and so when we're reflecting it across the y-axis, our rule is x negative y. So we apply our rule, and we get negative 1, negative 2. Okay, so when we plot this point, negative 1, negative 2, and there's point T prime, you'll see that T to T prime went directly across the x-axis right here. It's like that x-axis was a mirror. Alright, next, point R. Point R is at 1, 2, 3, 1, 2, 3, 4, 0.34. So we apply our transformation, and we get 3, negative 4. Let me plot this in here. 1, 2, 3. 3, negative 4. So there's R prime, or our image, right? So R is our pre-image, R prime is our image. And lastly, we have point Y. Point Y is at 2, 2. We apply our transformation, and Y prime, there's R prime and T prime, right? Our image. R prime is to negative 2. We plot to negative 2, get Y prime, and then we just connect the dots together, and it gives us that triangle. Alright, so what if we are not reflecting in the x-axis? What if instead we reflect in the y-axis? Well, starting with that same point, right, your xy, our y-axis follows the rule where xy becomes negative xy. So instead of changing the y value stays the same. This time the x value changes. And so we are reflecting across this line right here, right? So our y-axis is acting as our mirror image. So if we look at point, let's start this again, point T, and T is again at negative 1, 2. We are applying our transformation where our x value, the sign of our x changes, but our y stays the same. And so T prime becomes positive 1 and then just y, 2. So we can make this 1, 2. And there is our T prime. Okay. R is at point 3, 4. We apply our transformation, and we get R prime is negative 3, 4. Plot this. Get negative 3, 4. Alright, see how it's reflecting across that line? And then lastly, point Y at 2, 2 becomes Y prime at negative 2, 2. Y prime. And then we connect those points. And there's our triangle. Okay, next, what if we're not reflecting across an axis, but we're reflecting instead in a line? And this line is y equals x. Okay, well the first thing we have to think about is, where is line y equals x? Well, if we start at the origin, right, our slope is 1, there's no y-intercept, so our slope is at the origin. So the line we're talking about is this line right here. So what if this is our line of reflection? What if this is our mirror image? We want to flip that triangle TRY, over this line. Well, the interesting part here is, you see that point Y? Y is right at that line. Right? Y is right on that mirror line. So something interesting is going to happen to Y, and I want you guys all to pay attention to that. Okay. So again, triangle TRY, starting with T is at -1, 2. Okay. So we are going to apply our transformation, and if we look, our transformation, when we have xy, when we reflect it across y equals x, it becomes point yx. So the x and the y, their positions in that coordinate, they just flip. Okay, so our rule is yx, y. So t prime becomes 2, -1. Okay, so let's plot this. 1, 2, -1, and there's point t prime. Alright, let's do r next. R is at 3, 4. We apply our transformation. R prime is at 4, 3. 1, 2, 3, 4. 2, 3. Okay. And lastly, point y. Y is at 2, 2. We apply our transformation, and y prime is at, oh look at that, it's at 2, 2. Which is kind of interesting. So y is also y prime. And when we connect these three together, okay, I'm going to draw this line of reflection a little bit better here so we can see this. If we're looking, y is right at that same spot. It's like when you touch a mirror, you and the real you are both touching that mirror. Okay, that's what this point y is doing. If we look at t, see the distance from the mirror to t, the distance from the mirror to t, well, those distances, they're congruent. Okay, same thing with r. Those distances are the same length. And this goes for every line of reflection. It's just a little bit different when we have lines that aren't the origin, just because it's a little bit harder to count that actual distance. We still can, possibly using the distance formula, but it's just a little less straightforward. Okay, last example. What if we're taking, again, triangle TRY, but this time we're reflecting it in the line y equals -x. Again, we're still starting with point xy. This time our rule is that we're swapping the positions and we're changing from positive to negative or negative to positive. We're changing their signs. Okay. So first thing we got to look for is, where is line y equals -x? And that is, let me draw this with an actual marker. That is this line right here. Okay. We'll draw it in as a line of reflection. All right. So there's our line of reflection. Okay. So now we've got to plot our points. Okay. So t, again, is at -1, 2. Our rule is that we're swapping positions and changing signs. And so t prime is going to be at -2, 1. Alright, so this 2 changes position, so y becomes the x, and we change the sign. And then the 1, which was the x, becomes a y, and we change the sign. So t, let's go, -2, +1. So there is t prime. Okay, next letter, letter R. R is at 0.43. We apply our transformation. R prime becomes -3, -4. There's R prime. And lastly, point Y, which is at 0.22, transforms to be point Y prime at -2, -2. And there's our triangle.